This is Algebra 2 with Trig, working on Unit 2B.2a. We're adding and subtracting and also multiplying polynomials. So here we're starting with two polynomials that are being added together. So one way to do it, when you're adding, you don't really need the parentheses. So you're grouping like terms together. If you wanted to bring the like terms together, that guy moves over, negative 2x squared moves over, 4x is being grouped together, and negative 4 is being grouped together. So we're adding this together. So negative x cubed, positive 2x squared, negative 7x plus 6. So we added our two polynomials together. On this side, we are subtracting two polynomials. So to subtract, you need to distribute. The parentheses are needed on the second polynomial. You need to subtract, so you're going to get a positive 4x cubed when you do the opposite or distribute a negative to a negative. A negative to a positive is negative 6x squared, negative 9x, and positive 3. And then we add these two polynomials. We group the like terms together. We've already used the negative. We've already done this subtraction. So that is 7x cubed minus 2x squared minus 2x plus 15. When you're subtracting polynomials, it's much easier to get the sign wrong. Many people only subtract the first term, change the sign of the first term, but they forget the parentheses, so they never distribute it correctly. Here we're going to be working with a function notation, h of x. H of x is this polynomial. So we have 3x squared minus 4x plus 7, and we're subtracting, so you have to use parentheses because we're subtracting this polynomial, the k polynomial, which is 8x plus 2x squared minus 3 plus 9x cubed. Now I had to use parentheses around this polynomial because we're subtracting, because that helps remind me and allows to distribute our negative through the whole polynomial to actually subtract it. So I have a negative 8x now, and a negative 2x squared, and a positive 3, and a negative 9x cubed. So then we come through, we're adding these two rows together. So I have negative 9x cubed here. I have negative 2 and a positive 3, so positive x squared, negative 12x, and a positive 10 by adding the 7 and the 3, the 4 and the 8, the 3 and the 2, and the 9. So again, when you subtract, you must use parentheses to subtract a polynomial. Now adding is pretty simple. Adding is just doing the like terms together. So our k function and our g function, if you're working with adding two polynomials together, parentheses are not necessary. They just get in the way of thinking that you've got to multiply. So we're just collecting like terms. We have a 9x cubed, so we've used that one. we have a 3 and a 2, so we have 5x squared. Negative 4 and positive 8 gives us a positive 4x. A negative 3 and a negative 2 gives us negative 5. So we're just grouping like terms together. Parentheses are not necessary. Here we are adding the f function and the g function. The f function is 4x cubed plus 9. And the g function is 3x squared minus 4x minus 2. So we have 4x cubed plus 3x squared minus 4x plus 7. The only like terms was our 9 and negative 2. Everything else did not have a like term to it. Here is subtraction. Gotta watch your subtraction. So we have 3x squared minus 4x minus 2, that's the g function, minus, now we must use parentheses around the h of x. So we have 3x squared minus 4x plus 7. To subtract correctly, you must distribute your parenthesis through. To do that, we're going to have a negative 3x squared, a positive 4x, and a negative 7. So those are the same terms but opposite signs, so they cross out, and the final answer is negative 9. That's the difference between g of x and h of x. Here we have two polynomials. We're going to multiply them together. And when we multiply them together, your first term is going to multiply the first term, 6x cubed. The 3 and the 2 make 6. The x squared times an x. We learned the lesson that when you multiply the same base, you add the exponents. And this exponent is a 1. So we're going to add 2 plus 1 to give us 3. Then we have a positive 9x squared. This would give us 6x squared plus 9x. Then we multiply through by our 5 all the way through. We collect our like terms, which is our 9 and our 6. So we have 6x cubed plus x squared and x squared is going to still make x squared when you're adding them, but 9 and 6 make 15. When you're adding x's, you're still going to get x, but it's 9 and 10 make 19x because we're adding. Adding doesn't change the exponent. Only multiplying changes the exponent. Here's a little bit different notation where we're using a dot to represent the multiplication of the two functions. So in this case you do need parentheses. So the x squared is going to go to the x. So 2 and 1 make 3 because we're multiplying. We got x times x to make x squared and x. So that's 3 different x's. So that's x cubed. So negative 5x squared. This would be negative 2x squared because negative 2 times 1 is negative 2. X times x is x squared because there's 2 different x's there to make x times x. And then we have to take the negative 2 also to the negative 5 to make a positive 10x. And then we have 3x and we have negative 15. So that leaves us with an x cubed. collect your like terms together to get negative 7x squared. You don't change exponents when you're adding or subtracting. 13x minus 15. So we're writing the polynomial in standard form. The exponents are in descending order. Now we have three different polynomials. We'd call each one of these polynomials really a binomial. Each one's a binomial, and we're going to make an even larger polynomial. So the first term you can just drop down. You could really drop down any of them. It doesn't matter which two you're going to work with, but I'm going to FOIL our x squared positive 2x minus x and a negative 2. So you FOIL two of the terms together and you bring down the third one. I'm still bringing it down as I collect my like terms. In the middle, I have a positive 2 and a negative 1. You do not change exponents when you're adding or subtracting. Now it's just like the previous problem we did. We'll take our first term. So x times x squared gives us x cubed. X times x gives us x squared. X times negative 2 gives us negative 2x. Notice the degree always goes up 1 when you multiply by x. Then we go through with the negative, and we multiply each of the terms of the second binomial or trinomial by a negative. So we collect their like terms. We have a positive x squared and a negative x squared. Those would cross each other out. Otherwise, we have x cubed minus 3x. That would be both of those. And then a plus 2. I like to make some sort of mark on them to show that I've used them in the calculation. We'll do the same thing. We'll just keep our pattern the same. We'll bring down the a minus 5. We'll distribute a squared 6a plus 2a plus 12. Now, if I'm going too fast with any of this, be sure to pause the video, try the problem out yourself, then run the video and see how you're doing. So I'd encourage you to pause it here, complete the whole problem, and see if you're going to match. So now we're going to have a minus 5. We're collecting our like terms. So a squared plus 8a plus 12. Now we come through and multiply through. So a times a squared is a cubed. 8a squared plus 12a minus 5a squared minus 40a minus 60. And we collect our like terms. There's our cube, our square, and our square gives us 3a squared. Our a and our a give us negative 28a, and our negative 60 is our constant value. So now you can check to see if your work was accurate, and you're getting a much better learning process to see what type of mistakes might you have made rather than just copying down what I'm producing. Now we flip it over. Now we look at some more special shortcut patterns. These are all ones that we've somewhat talked about before. This is a conjugate. When the two terms are the same, a, b, and a, b, they're both the same, but the sign in between is different. They are called conjugates. So they're a conjugate of each other. So if you were to FOIL this, you'd get a squared minus ab plus ab minus b squared. Notice what conjugates always do. The middle term crosses out because it's a positive and a negative, and when you multiply through, you get AB and AB, which disappear. So we're left with a squared minus b squared. That is the difference of two squares. So what we've learned about in the past is to factor that one apart, and we turn it into this. Now we're going the other direction. Here we're going to take our a plus b squared. It's a binomial squared. What polynomial is made when you square a binomial? Well, you cannot distribute. It's not a squared plus b squared. That's a very, very common mistake. We need to write out the two binomials twice. So we have a plus b and a plus b because a plus b is squared. They're multiplying each other. Then when we FOIL it, we get a squared plus ab plus ab plus b squared. Notice the middle terms do not cross out. We get a squared plus ab and ab gives you 2ab. Then you have your b squared. So what we learned earlier in a different lesson is that if you have this pattern, then it's a perfect square trinomial. It produces a binomial squared. Well, now we're watching what the polynomial is being produced. We look here and we see conjugates of each other. So really with the conjugates, all we have to do is multiply the first terms, multiply the last terms, and that's the shortcut, because the middle terms are going to make positive 15 and negative 15, so they'll cross out. So there is no middle term. 3 and 3 make 9. H and H make h squared. Negative 21, positive 21 would cross out. Then you're left with 7 times 7, which is 49. So if you have conjugates of each other, which we have, we're going to make another binomial. They're both squares, perfect squares. So working backwards in terms of a factoring idea, if you have the difference of two squares, then you have these conjugates. We're working to make the polynomial. Here we have a binomial squared. So what we're going to do is consider this our a term. Consider that your b term. So our pattern, remember, was a squared plus 2ab plus b squared. So what we're going to do is take our a term, 4a, and we're going to square it. 2 times 4a times the b term plus the b term squared. So we can simplify that into 16a squared plus 28 times 2 is 56a plus 49. So we did not do a whole foiling format to make this happen. You could write this out twice and foil it together, and you do not need to know the pattern. So if you need to just do it the traditional way, it'll still work. But this traditional way is supposed to be a little bit quicker. Sometimes you can do the calculations and not even have this process calculation in here. So here we have fx squared. So that's just function notation about squaring your function. Here is your function. So we are squaring 9x minus 2 because you're squaring the f function. So when you square the f function, you end up getting 9x being squared. you have to multiply the 2 together, which is 18. 18 times 2, remember the pattern, 18 times 2 gives us 36. This is going to be a negative 36. And then we're going to square our b term, which is positive 4. So that's a real quick way to calculate out a binomial being squared. Here we take a word problem. It talks about the models below, which is your D and your C. They give the average depth in feet of new wells drilled. So this is the depth that a well, a big hole in the ground, a cylinder going really deep, this is the average depth. So if you have a whole bunch of houses, they may not be all the same, but when you add up all their depths, they have an average. This is what it is, kind of like for this community. And the average cost per square foot, or per foot deep. It's not a square foot, but it is the cost per foot to go down. It would be this equation. So what they're asking is, what operation would you need to perform on the D and the C to find the model for the average cost of drilling a well, the total cost of drilling a well. So if you know how deep you go and you know the cost per foot, you would need to multiply the C function times the D function, or vice versa, to figure out your total cost of how much it would be to drill your well. You would need to know how far down you go, and you need to know how much it costs to go down. This is your average depth. This is your average cost per foot. Alright, back in geometry, you could have learned about a solid or three-dimensional figure. This is called a square pyramid. We see the two sides are the same. They give us the formula. It's 1/3 capital B. The capital B is the base, the area of the base. So the area of the base is the square. So for us to figure out the area of the base, we have to do length times width, or S times S, since it's the same. And then the height, of course, is the perpendicular from the center up. So our volume is going to be 1/3 2x minus 3 squared times our height. So now we're looking at some calculations that were similar to what we've been doing. Here we're squaring a binomial. We cannot distribute the 1/3 through first. We can't multiply by this binomial. So we're going to square this one. Remember, what we learned about squaring is you square the first term, you multiply the 2 together, which is -6, and times it by 2. That was our formula that we had earlier. Up in the previous problem, we talked about how you do this. You 2 times the A and the B. So we have to do A times B, -6, times 2, which is -12, and square the last term. And we still have our 3x plus 4. So this here is the area of the base. Now, we could distribute our 3 through if we wished, but typically you're going to work with the two polynomials first. So 4 times 3 is 12, x squared, and x gives you x cubed. 4 times 4 is 16, x squared, -36x squared. 12 times 3 is 36, x times x is x squared. Negative 12 times 4 is negative 48x. Now you got to go through with the 9. You get 27x. And you get 36. 9 times 4 is 36. So all of that is being affected by this 1/3. But before we do the 1/3, let's collect our like terms. So we get 12x cubed. That's the only one with an x cubed. The 16 and the negative 36 are going to make a negative 20x squared. The negative 48 and the positive 27 leaves us with negative 21x plus 36. And then to distribute our 1/3 through. So 1/3 of 12 is 4. 1/3 of 20, it doesn't go in there evenly, so we call it 1/3 x squared. 1/3 of 21 is negative 7. And 1/3 of 36 is 12. So this would be the volume of our square pyramid when you multiply the dimensions that they give you. So if you knew what your value of x was, you could then plug it in here and do your calculation to figure out the volume of our pyramid. Last one. Here we have a square. Kind of like this. And then we're going to come through and we're going to cut out this portion that's in the middle. So we come in here. And we cut that out. Did a great job. Alright. So I cut that middle portion out. So if I know the dimensions that I cut out and I know the dimensions that I have, what's the rest of the area around? Well, if we know the whole piece is x plus 1 times x plus 1, that gives us x plus 1 squared. And we just subtracted, we just took this out of it. So we subtracted 5, x minus 7. That leaves us with multiplying and trying to figure this part out. We have to square this binomial. You cannot call it x squared plus 1 squared. You cannot distribute that through. You either got to write it twice and FOIL it, or you've got to use the square the binomial rule. So we square the x term, we multiply these together and times it by 2, and we square the last term. Negative 5x and positive 35. So the area is all dependent on what the value of x is. If the x is somewhat small, then the area is going to be small. If the x is larger, then it's going to be larger. So here we're going to have x squared minus 3x plus 36. That would be the area of the shaded part of our figure. Hope that helped.